would like to use this opportunity to kind of step back and take a long view and look at the computing history and the evolution of technologies, and from information retrieval all the way to today's large language models. And so one theme here is about AI in general and its impact on society. So we're going to take a look at the technology development, because this course we're very focused on a specific technology, which is search engine, right? Information retrieval. And sometimes when we are so fine-tuned and focused on the mathematics and the inner workings of something, we can lose sight of the bigger picture. So I would like to step back and invite you to take a long view of the big picture from the historical point of view of computing, as well as looking forward, right, to the future of this technology development. Because today we are all excited about AI, but we also got to understand the limits of AI. And when we try to apply the technology to applications, we need to be aware of these limits so we know what to avoid and where the dangers are, right? And also, that also gives us the mindset about how we can improve the technology for the future, for future generations as well. So let's get started. So first, I would like to talk about computing history and multiple kind of parallel developments, and to talk about the convergence of technology to today's AI development. So let me start, because I'm from Drexel University in the city of Philadelphia. So Philadelphia is a major city in the US, and the name actually means the city of brotherly love, right? So if you see the corner here, right? So right here, this is a picture of Philadelphia. The symbol, the love symbol especially, is a symbol for Philadelphia because of brotherly love. Now, the reason I mention Philadelphia, because it's really the beginning of this country, of USA. The revolution, the American Revolution, started right here at Philadelphia, and the country was established about 250 years ago, right? 1776, right? With the Declaration of Independence here, right here in Philadelphia. So to talk about history, the history of something, I couldn't ignore or skip Philadelphia as a city. But the second point I would like to make is that Philadelphia is not just the center for the US history, but it's also a center for technology and innovation as well. So, up here, this is Drexel University, right? We are a part of the city of Philadelphia, and then across the street, right? So if you just walk from here across the street, you will visit the University of Pennsylvania, which is, of course, even more famous for its higher education. It's one of the Ivy League institutes, and really famous for its technology innovation, but also in business and other areas and industries. So University of Pennsylvania, and if you have pay attention to technology development, especially in computing, right? The first computer, and if some of you remember, which is called ENIAC, right? ENIAC, it was developed at the University of Pennsylvania. Okay, let me turn off my along. So this was the first computer in the whole world, which was developed at the University of Pennsylvania for military. Okay, so early development of computing happened right here in the city of Philadelphia, our neighbor at UPenn. And so it was initially developed for mathematical calculations, for decryption, and specifically for military research, this notion of ballistic research. Like if you try to shoot something like a bombshell, right? You want to hit the target, right? This was during World War II. Remember, an important time reference is this. This is in the early 1940s, and there was still the World War II ongoing against the Nazis, against the the evil states. And so if you want to defeat the enemy, you want to make sure that when you hit, when you try to attack, you are going to hit the target. And so this important research of computing was to help do the accurate calculation, so that whenever you shoot the bombshell or whatever, right, ballistic missiles, you are going to hit the target and cause more casualty on the other side, right? That is the whole purpose. And of course, this computer at that time was very fast. It was said to be like 5,000, was capable of calculating additions 5,000 times every second, which was really fast at the time. Of course, today, in today's world, is really slow, right? It's even slower than a regular calculator. But this was early computing, and the notion of AI was already proposed. Okay, so in 1956, the Dartmouth Conference coined the phrase AI as a reference for machines problem solving and reasoning. And Alan Turing was also an early pioneer in this area of research. He was also a pioneer as part of the team separately in Britain, in Great Britain, developing another computer. So they also developed another computer, ENIAC, maybe even earlier than ENIAC, but because of the secrecy of the military, it wasn't known to the world until a much later stage, a few decades after that. But Turing was known for his famous Turing Test, right? If you work on AI, you know what Turing Test is. What essentially Turing Test is about is that if you put an interface, right, perhaps a screen or some kind of a typewriter that you can interact with a machine behind the interface, right? It can be a machine or it can be just another human being. You couldn't tell, right? But imagine if you just interact with this interface, just write to each other a message and try to have a conversation. And if you cannot tell whether there is a human being or a machine behind the scene, then the machine essentially passes the Turing test, because like you couldn't differentiate a machine from a human person, and that is a success, right, for AI research. And so there was also this early development of the Perceptron network, which was the first version of artificial neural networks. And of course, neural network is the biggest thing on earth today, right? All the deep learning large language models essentially are based on neural network. And so this Perceptron network was first proposed, and it caused a lot of excitement back then and lots of promises. But we have to know that the early development of perceptron neural network, even though it showed early promises, it also had its limits, right? It's very important to know the limit of these models, because if until then we may overpromise, And indeed, at that time, our researchers overpromised what perceptron neural networks can do. Okay, so what we later realized theoretically was that these perceptron neural networks is only capable of so-called linear problems, right? Linear problems are simple problems where you can basically draw a line just to separate two groups of, of entities, and that is what we refer to as a linear classification problem, right? I think you are in data science, maybe you have already learned about some of these models, but lots of problems in the real world are non-linear, right? There are lots of non-linear problems that cannot be separated by linear lines. So let me try to draw maybe a couple of things, right? So, right, imagine if you have a number of dots right here, right, and then red dots, right? Right. So if red dots and blue dots belong to two classes, and you try to draw a line to separate them, here it's difficult to draw just a straight line to separate them. So perhaps you need a curve, right? A curve like this to separate the two groups. And in this case, this is a nonlinear problem, right? That cannot be separated by a linear function. Of course, a linear function on a two-dimensional space is a line, but on a three-dimensional space is a surface, right? It's a plane, okay? And of course, on a higher dimensional space is a hyperplane, but essentially it's still a linear function. And so certain things just cannot be drawn as a linear function. And so this is a very simple example of like, okay, XOR, right? XOR is exclusive OR. Like, I'm not sure, as a kid, maybe you remember at the time when your parent told you like to either eat or play, but not at the same time, right? So like, okay, John, if your name is John as a kid, and let me say, John, you either go to eat or you can continue to play, but not doing both, right? So this is like either or. And perceptron neural network actually will struggle with this, like looks like a very simple problem, this simple concept of XOR, okay? It's impossible for such a linear model to capture the basic concept of XOR. So this is kind of the early development of AI, and then later on in the 1960s and 1970s, computing continued to improve, right? So from the early days of just this simple machine to do calculations, now they develop the mainframes for general purpose computing, and which can support larger scale multiple users at the same time, which with the time sharing, they can actually run computing processes at the same time, which at that time was great. Like you don't have to wait until the other job to be done before you can enter and access the computing, right? And IBM, or International Business Machines, was the leading company in this age. So along with some really cutting edge operating systems such as Unix, okay? And so this was the development of, large mainframe machines that were used by businesses, universities, and research labs. Now, in the 1960s and 1970s, there were also parallel development, like because of the computing power, right? There are certain programs that were developed on top of, right, the computing infrastructure on the hardware. And so there are some popularities of symbolic AI, right, with the rules and logic to perform specific tasks. There are also general problem solvers to mimic human strategies, and they are expert systems for specific domains such as chemical analysis, medical analysis, diagnosis, and so forth. There was this early example of natural language processing, NLP, right? ELIZA, for example, with an early kind of system for NLP for kind of medical or psychological therapist. And so it follows kind of a very prescribed way of interacting with the patient, which may have a psychological problem or something to talk about. So if you look at the conversation here, right, even though it sounds like to some degree human conversations, you will tell that it's rather prescripted. So you see, like, okay, I am depressed, right? So whenever the system detects I am, right, it's like an adjective and it describes a certain subjective feeling. And so it's going to say, do you enjoy that, right? So it's very prescribed. And now the person is actually saying, I'm depressed. Like, how can someone enjoy depressed? But because it's already programmed to respond to that I am statement, so it's going to say, do you enjoy being depressed? And of course not, right? And then the AI will continue to say, why not, right? Just to follow up on that question. And then when it says, I want to be, and again, this is kind of the keyword, it will detect like, oh, you want to be something, that must be, and come to follow up with the question like, why do you want to be, right? Even though should be intuitive, like I want to be happy. Who doesn't want to be happy, right? But AI here, ELIZA, is going to say, why do you want to be happy? And so, yes, it's going to be able to have some kind of conversation, but very often you're going to realize that it's sometimes absurd, right? It's weird to have this kind of conversation. So it's not really intelligent. It's very much scripted. Okay, so, I mean, in the 60s and 70s, AI also experienced this AI winter. And so because earlier there were over-promised models. So models such as the early Perceptron model were realized by many people to be over-promised on because people realized there were lots of limitations on these models, and there are simple problems that they could not understand, okay, and that is a big disappointment. And so there was this light here report, okay, and which basically very much criticized the advancement of AI and said there's really limited advances in the area, and so there was a shift more to the expert systems and kind of problem solving in a very specific narrow area for AI research, and that is the kind of the first AI winter. Now, during this time, from 1970s to the 1990s, this is also the especially in the 1970s, it was the pre-PC revolution. With PC, I mean personal computing, right? We talked about, Microsoft, IBM's personal computers and other PC manufacturers, as well as Macintosh, right? Before Macintosh, there was actually Apple's, like Apple II, which was revolutionary, at that time. So anyway, so during this time, I call it pre-PC revolution because they were kind of they advanced from mainframe computers. Mainframes are huge, and they were used by big companies. And so for smaller companies who wanted to have a taste or use of computers, they were so-called mini computers. Even though they were called mini, they are still sizable. They are still big, almost like your refrigerators or appliances at home. They were much smaller compared to mainframes, but they were still sizable. computers, and they have this subscription model. So you can basically use your Teflon line and have a terminal to connect into the mini computer and have a share of the computing time, right? And you get charged by how much time you spend on the computer, okay? And if you, I'm not sure if you can recognize these two little students here. They were high school students, and if I tell you the names, you probably now realize this is Bill Gates. Bill Gates, of course, was the founder, the co-founder for Microsoft, right? Next to him was Paul Allen, the other co-founder for Microsoft. And what they were doing is using these typewriters. Okay, these are typewriters, okay, keyboards, and they can also print. But they also connect to a mini computer somewhere, maybe miles away, which is DEC's at the time. DEC's PDP-10. And so they had that access through their school's program, and the parents pay for that kind of subscription so they can learn languages such as basics. Okay, so there was Paul Allen and Bill Gates using the subscription model to connect and to access computing resources. And so that was the early days in the 1970s. And of course, later, they would start the PC revolution, right? This was actually the first, like most people would believe that this was the first computer, first personal computer in the whole world. Okay, this is called Altair 8800. This was created in 1975. And if you look at the interface, it's really absurd to people today. So there are two set of things, okay? So let me use the blue to highlight the input, okay? So the input are essentially just switches, okay? The little switches, you can push it up, press it down, and what it means is basically 0 and 1, okay? Depending on which direction you push, right? It's 0 or 1, right? If you push it up, it's 1. If you leave it there, it's 0. So you can basically create a sequence of code, okay? Basically binary digits in the 0 and 1s, right? That is your input. And then the red that I highlight here are the lights, the indicators. And that is the output. Again, if the light is on, it means 1. If the light is off, it's 0. So this system requires all binary interaction, right? You need to convert everything into binary code before you can interact it with this machine. But for people at the time, it was a huge thing because, like, for a few $100, you can actually own a computer that can follow your instructions in binary code. Okay, but of course, this was kind of becomes too complex. Like, you know, if you mess up something, you have to redo everything from the very beginning. So in the end, Bill Gates and Paul Allen, right, they were able to kind of plug the keyboard and monitor in, and also they create the basic language interpreter for this. So people can actually use the programming language of BASIC to program. And this was thanks to Bill Gates and Paul Allen that started the company for Microsoft. And then, of course, next to it is the Apple II, right? This is the Apple II computer, right? Created by two Steves, Steve Wozniak, right? And then Steve Jobs, right? Steve Jobs is more famous because he later would also invent iPhone, iPad, and Mac, and everything associated with those, right? So that is the Apple. But then there was also a later technology, and this is called GUI, right? Or graphical user interface, graphical UI, right? The notion of GUI in the 1970s was a revolutionary concept because everything was based on a terminal, like typing and character based. But the notion of having a mouse, you can see that there is a mouse next to it, right? And then there's a screen with kind of windows. You can move things around with icons and everything. And obviously, Apple would steal the technology there. Microsoft would steal the technology from there. So they both copy the technology from this GUI interface. And the company behind this development was Xerox. It's PORC. It's a research lab in California. Xerox is a copier machine company. I think they are still doing copier machines. But if they could have used their own technologies, they could have become the biggest company in the whole world. But unfortunately, their technologies were appreciated by those revolutionary forces like Bill Gates and Paul Allen and Steve Jobs and Wozniak, that the other companies, Microsoft, Apple, became much more successful compared to them, right? So that became the history. But this started the PC revolution and the fast growth of PCs in the 1980s and 1990s, right? So there was better hardware, like Intel CPUs. There was also better software, right? From terminal character-based interfaces to graphical or GUI interfaces, right? Windows, Macintosh, icons, graphics and things like that. So there were also more or better graphic hardware for games as well, right? So in the 1990s, this was also the founding of NVIDIA, right? And NVIDIA is huge today, right? Because thanks to the AI revolution, and people in the AI world need NVIDIA, the GPUs to run the machine learning or AI models. But they started as a graphic hardware company to support gaming, right? And so during that time, this is also the second AI winter, because again, AI was overpromised, and then people realized again it was limited, right? It couldn't do things that people wanted to do. I mean, not just because of software, but also model was improved, but of course because hardware at the time was not enough to support the kind of intensive computing that the models require. And so people move away from early development of symbolic AI and expert systems more into emerging machine learning and deep learning, right? But again, this was the early stage of machine learning and deep learning. The ideas, actually lots of the ideas that we are enjoying today were already proposed in the late 1990s or even early 2000s, but researchers were not able to capitalize on these ideas because compute was not there, right? If it takes years for you to train a model, right, you just cannot do it. And so that time in the late 1990s to 2000s, and I was fortunate enough to be in the industry, working with some of the leading companies back then. So I had my first-hand experience in the industry. In fact, I worked with, I was a manager at eBay. I was also spent multiple years as a chief engineer at this company called Lycos, which was world's first web search engine. Okay, maybe, I'm not sure if I talked about it early in this class or not, but Lycos was actually before Google, right? Before Google became big, Lycos was bigger. But unfortunately, or fortunately, Google overtook early search engine companies and became much more greater. And so Lycos is no longer well known. But I'm talking about at that time, in the late 1990s and early 2000s, there was this dot-com boom, and there was lots of new internet companies, right? Yahoo for web directories and portals, eBay for e-commerce, and then Lycos for web search engines before Google and others came along. And then of course later there would be Google, right? And Google's interface at the time was revolutionary, because don't underestimate this search box in the front and center because back then nobody did that, right? I said I was with Lycos when we were at Lycos. At the front and center were the contents and all that news and exciting stuff, right? Happening. And so you have lots of information in the middle, and then the search box is on the side, at the corner, a small box. And that it was the common practice back then. But Google, because they lack staff, they don't have people to put all of that front and center, they just put the empty search box front and center, and that becomes their kind of the symbol, right? And that became also very successful because they were really good at search compared to other search engines. All right, so that's search. And then there was also later YouTube, right? And that represents the social media for video and sharing, right? And then there's social media such as Facebook to connect with each other and have friendships and friends network and update each other. So social media, AI, and search. Now the point I'm making is that as part of this search engine and social media development, there was also huge demand for AI. Because think about this, when you go to YouTube or when you go to Facebook, or in China maybe you go to TikTok and Weibo and other social media sites, and those sites will try to give you and recommend the best content for you, so you are likely to click on and watch and consume the content, because they is where the revenue will come from, with advertisements and among others, right? And so making the right recommendation based on your past data and behavior, that's the very notion of machines learn to make recommendations, and that is AI research. So social media and search engines demand kind of heavy AI research, whether it's about YouTube or video content, media consumption and recommendation, or shopping to recommend the product, or advertising to be able to push the best advertisements or commercials to you. These are all about business, and so be able to make better predictions based on past and user data is critical for the development and kind of profitability of these companies. And I do want to highlight two things during this age. One is personal. Okay, so if you have looked at the development until this, there are two major keywords I would like to argue. One is like personal. Computing became personal, right? From the early days of ENIAC, right, as more of a calculator, to mainframes or even mini computers, they were used by big companies for big business, right? But later would come this PC revolution where computing became personal, right? Whether it's your personal computer, your mobile phone, your personal email account, your calendar, and so forth. These are personal. So personal is one keyword. And then the other is the interconnected, right? So internet was the kind of the first, or the infrastructure to allow you to be able to interconnect with each other. But then there's web, there's social media, right? There are different apps for your communication with friends and colleagues and co-workers and things like that. So interconnection is another part of it, right? We want to be personal so that the machines or software or hardware will be able to serve me, but in the community where we can interconnect and exchange ideas, right? And so those are two keywords I want you to think about during the AI age, okay? And so with that, let's move into kind of the AI foundations and talk about some of its limits and implications. I think some of the slides that I prepared here we have already covered, so I'm going to quickly go through some of those and go straight to the limits and implications, okay? So let me double check. At this point, I believe I'm about 35 minutes, so I may still have 15 minutes to go with this presentation because I want to stop at about 50 minutes mark, so I still have some time to interact live with you. So this is a picture I hope that captures kind of the 50-year development from 1970s all the way to today, right? So 50 years ago, there was Bill Gates and Paul Allen interacting with the computer miles away using a terminal, right? And nowadays, any two random kids can interact with the AI model through their computers. But there's one thing in common, which I don't necessarily like, and I think future development will change this. And I'm putting it here is that both of these are based on a subscription model, right? So in order to use the computer, you have to subscribe to the resource. Think about at Bill Gates and Paul Allen's time, the whole reason they helped started this revolution, PC revolution, is to have a PC, a personal computer on your desktop, so that you don't have to subscribe to the big machines, right? And I want you to think about this. Right now, we are subscribing to the big machines, right? Software, but also hardware, like OpenAI, right? Like Google, Microsoft, and all the others with all the cloud resources. But we basically pay our subscriptions to have a share of the AI models. But can we potentially have a personal AI model that is right here with me on my computer, serving me, understand all my data, and without my permission is not going to leak or use my data for other people, right? That is my question for you. Now let's continue from here to talk about some of the key advancements in AI, right? So social media, as I said, demands better AI because they want users to produce and consume content, and they want to drive profits and enable communication. There is advancements in software for recommender systems, so machine learning, deep learning, reinforcement learning. There is also improvement of hardware, right? Not just in CPUs, but more important in GPUs for neural network training or pre-training, supported by hardware design for NVIDIA and the manufacturing of TSMC, right? So these are some questions that you may want to think about. I don't think I'm going to get into some of these questions. And regarding the age of AI, some people are very optimistic, others are pessimistic, right, about AI takeover. Do you share some of these emotions or sentiments? What is going to be the impact of AI on the job market, right? Compared to the previous generations, the PC revolution, the internet revolution. So if you think about a PC, right, it did take away people's jobs, right? Internet is shifted the communication, right, from big media companies into social media, right? There is also impact on communication, on learning, on education. Right? There are concerns about current AI offerings, whether it's subscription model, right, which is leading to monopolies, There's all concerns of data privacy, sensitivity, right? Bias in AI training, safety and security, copyright issues, human creativity, original thoughts, critical thinking, and education. There are lots of different areas we need to think about regarding the development of AI and its implications. But I would like to move forward from here to talk about a few things. And let me kind of go through some of these slides because I think we have touched on some of these. So there has been a big leap, right, from early binary instructions to interact with the computer to today's natural language instructions. So there's a difference. And we have talked about some of these models, right, in information retrieval, in text mining, the back-of-words approach, and we also cover a little bit of language modeling, right? Probabilistic models for auto-completion, right? And I think in the previous week, we also discussed large language models with two pillars, right? Word embedding and attention, right? As part of the transformer architecture. And so we did go through these together. And so what I ultimately would like to say is that large language models are large, right? They are in today's world, when we talk about large language models, they are essentially pre-trained transformers. So part of it is the GPT, or the generative pre-trained transformers, right? Because that is the fundamental model with the embedding and attention, right? And so they are large because there are lots of parameters to be trained on, right? GPT-4, this was from last year. It reached already a trillion parameters. Llama, which was smaller, again, this was data from last year, up to 65 billion parameters. Alcapa, right? Consider a tiny model still has 7 billion parameters, right? So these are large models, but compared to the whole world, the internet, the model is still relatively small, right? Think about the amount of data that potentially can get into, be used to train those models. It's massive, right? So the models, relatively speaking, even though they are called large language models, they are relatively small. And so essentially the kind of essence of large language model is trying to compress, right, all the massive data from the internet, from the public and private domains, into the representation of large language models. And so you kind of compression, if you think about the idea of a compression is basically I try to capture as much as possible with the limited space that I have, right? Because with compression, and this is not lossless compression. This is going to have some loss. So you're going to lose some data in here, but still you try to use this limited space to represent as accurately as possible the entire world of data, so that later, after this model is trained and compressed, right, you will be able to use it to regenerate the content that have been used to train the model. So I hope this makes sense. So the essence of today's large language model is this notion of compression. Okay. And so again, as I mentioned, in GPT, there are two fundamental technologies, the word embedding and attention, right? So with GPT, you basically know if you use GPT for AI, the AI will have knowledge of language representation. If you train all the data in English, it's going to know how to speak, right, English. If you use all the data from China to train the Chinese AI, the model will be capable of speaking Chinese, right? I hope that makes sense. But having that model is only half of the story, because knowing how to speak doesn't mean it's going to have a conversation with you. Think about this. This is my favorite example, right? So you probably are too young to have kids at home. But think about if you have a cousin or maybe nephew, right, that is much younger. And so maybe let's say just a toddler of 2 or 3 year old, right? They know how to speak, probably, right? They speak some language, so they can speak. But that doesn't mean when you ask them a question, they are going to answer you, right? Because unless you give them candies or play with them, their toys, and they may just ignore you completely when you ask, like, what's your name? They may just go away playing toys, right? So having the knowledge or language representation and knowledge doesn't mean they will have a meaningful conversation with you. That requires training too. And that is the part that OpenAI really pioneered, which is to train or fine-tune the model to follow instructions so that you can actually make the model to have a conversation, which is the second component, which is what I refer to as the chat, right? So ChatGPT, as an example, is not just GPT, but also chat, the ability to have a conversation, okay? And that is more of a behavior. Think about a toddler, 2 to 3 year old child with the knowledge representation, but you also need to kind of train or parent the young child to be able to have a good behavior, to have a conversation, right? So that part is usually rely on this notion of reinforcement learning. I'm not sure if you have learned about reinforcement learning in other classes, but the basic idea of reinforcement learning is like if you have a pet, right? Like a dog at home, you try to reward it with actions, like, okay, sit, and then if it sits, you give the dog some treat, right? Of course, if it doesn't do it, you don't necessarily beat it, but there can be some penalty, right? And so, so through rewards and penalties and observations, that dog or whatever model you're training will be able to follow your instructions. And so there are lots of ways reinforcement learning can be used to support behavior training, to enable AI model to have a conversation, among other things, right? So there's reinforcement learning with human feedback, which is OpenAI spend lots of effort on. There's also the self-play with reinforcement learning. Remember a few years ago, there was this AlphaZero for Go by Google, right? They program the train these AI model to be the best human Go player in the world, okay? And AlphaZero was really capable of just play itself. Like, I play the Go game or chess game, and I place against myself, and by doing that I learn a lot, right? So that's the idea. And then there's mutual reinforcement learning with other agents. Think about, two players can play against each other and learn from each other, right? And that is applicable to autonomous vehicles like driving. So you stimulate different vehicles driving at the same time, and of course you want to avoid collision, right? So that is kind of the reinforcement learning. This is kind of the third major piece of technology as part of AI today, right? So all these developments point to some interesting, future, right? And there's indeed lots of excitement. But with this, I also want to remind you that there are also lots of limits in here. I just highlight just one because of the time limit. Perhaps I have 5 or 6 minutes to talk more. So I want to quickly highlight just a few things for you so that you know where the limits are, right? So I'm not sure if you can see this clearly, but I want you to see this line right here, okay? So this is the y is y-axis is about like accuracy prediction, right? So here is like 100%, almost like 100% accuracy. This is the best, right? And then this is the year, okay? This is the year of the development. And so one line you will see is this line. This line. So about 2016, okay, this line already reached like 100%, which is great. Like this was even better than human beings. And this line represents image classification, like image recognition. And I want to present to you this problem of, okay, like, can you classify whether this is a dog or a cat, right? Just presented a picture, classify whether this is a dog or cat. And more specifically, I think some task will say whether this is a Labrador or whether this is a golden retriever, right? Golden retriever is a special species of dog, right? And so now, even though these machine learning models can achieve 100% accuracy, it doesn't necessarily understand what a dog is or what a golden retriever is, because we understand the golden retriever by its characteristics of the head, right? The color of the fur, things like that, right? So if you train your machine learning model, you want to be able to say that, oh, based on the color and based on the kind of the characteristics and features of the head, you can do the classification. But unfortunately, the AI model, and part of it, a big part of it, is actually not focused on the dog itself, but focused more on the grass. Okay, grass or the green color is actually one important feature that these AI models use to project golden retriever, because it's often the case that these dogs will sit on the green grass lawn, okay, to be pictured. And that's why these models are successful. But unfortunately, this is a misunderstanding, right? Due to the machine learning. But they led to great performance, 100% accuracy. So just because something can predict 100%, and the message is this, just because something can predict 100% accurate doesn't mean they understand the task or the concept, for example, of being a golden retriever. Okay, so very quickly, and I want to talk about just a few things regarding AI, and there are lots of challenges up there, but I want to kind of highlight this one major challenge. It's more like a dilemma, okay? I may have mentioned it earlier, but there is a notion of who will take responsibility, right? If AI is to make an action, right? So think about AI driving a vehicle in autonomous driving. If there is an accident caused by the vehicle, who is going to be responsible for that? And that is an important question to ask. Is it going to be the AI developer, the company, or whoever trained the AI tool, or people interacting with the AI tool, or who else, right? Or the person owning the car, right? So who takes the responsibility has lots of consequences in here. The best way that I imagine today's AI going forward is to be able to combine human creativity and AI efficiency, okay? But there are two limits we have to overcome in today's models, particularly due to model temperature, okay? So when model temperature is high, because these are probabilistic models, they tend to hallucinate, they tend to give you misinformation. When model temperature is low, they tend to replicate, and they will generate something that has already existed. In that case, there are going to be copyright issues. So we face this dilemma in terms of the model temperature, and I want you to think about how we can possibly solve this problem together. But more fundamentally, I think regarding the future of AI, this is what I see, right? When we are talking today's ChatGPT and among other models, they are large language models hosted by these big companies with the cloud data centers somewhere, right? And we need to kind of subscribe and connect to these big data centers in order to use them. We don't own them. We need to share our data with them and everything, and we need to pay them, right, to have a share of it. This was highly similar. This is similar to what we experienced many years ago, more than half a century ago, with IBM mainframes, right? You have the big machines out there, and people can connect into them and subscribe to them and pay for them, right? So that is the model of yesterday, and we're still following this model today, right? And the last slide, I believe, is what I believe to be the future. And I think hopefully we can all work together toward this future, which is more personal interconnected models using AIs. Think about today's age. It's an internet of PCs. Or by PCs, actually mean not just personal computers, but personal computing, right? Your mobile phones, your iPads, all the devices that you have, they are connected into the internet. This is today, right? And so what I hope that we'll be able to achieve together is the internet of personal AIs. So each one of us will be able to own and train and use our awesome personal AIs as assistants, and they will be able to connect to one another on our behalf and be able to search information for us using retrieval systems. Perhaps they will be able to have a conversation and and help us in certain tasks. But again, there are two keywords. One is the interconnectivity with the internet, right? The other is the personalization of these AI models. Okay, and so this is the way I see where AI should be heading, and we are not anywhere close to this model. We are still in the centralized subscription model with ChatGPT, with Cloud AI, among others. And we just have to continue to develop and improve these models. And at some point, hopefully, we'll be able to break away from these centralized monopolies of models and enjoy our personal AI assistants. Okay, so with that, I'm going to kind of end the presentation here. And I know this is going to be the last lecture, and I wish everyone continue great learning journey, and best luck in this academic program. And I will see you around. Talk to you later.